Waves are clogging the ocean's toilet, preventing phytoplankton poop from sequestering CO2 on the seafloor and speeding up climate change. Let me explain. Phytoplankton are generally photosynthetic organisms that get their energy from the sun, producing oxygen and absorbing CO2. They get eaten by larger phytoplankton and zooplankton that then poop out their carbon-rich remains. This fecal matter sinks to the seafloor and stays there, potentially for millennia, preventing the carbon or CO2 from entering the atmosphere. However, humans have messed things up. As we pump more CO2 into the atmosphere, we create higher temperatures in the ocean and sky, creating more common and intense marine heat waves that can actually clog the ocean's toilet. But how? Let me give you an example. 2 heat waves in the northeastern Pacific from 2013 and 2015 and 2019 and 2020 warmed the oceans. To monitor ocean chemistry and warming, scientists collected data from the biogeochemical Argo sensors that autonomously move up and down the water column, recording zooplankton phytoplankton concentrations. Winter winds typically blow and mix deeper and shallower waters, bringing nutrients from the deep up to the surface for larger phytoplankton to consume. However, in both heat waves, the warmer water remains warm, and the winter winds never came, leaving the warm, less dense water at the surface and creating a cap of sorts that prevents the warmer and cooler waters from mixing. This clogs the ocean's toilet, quote unquote, by trapping the fecal pellets in the warm water cap rather than sinking to the seafloor and storing the carbon. This dramatically changed the regional ecosystems. The smallest phytoplankton performed well in a nutrient-deficient environment because they don't require as much nutrients, whereas the larger ones decline, with the medium-sized ones eating the smallest ones that benefiting from the sudden increase in tiny phytoplankton. However, this means that as the larger ones passed away, the medium ones that replaced them had smaller fecal pellets that stayed floating there around 600 to 1,320 feet down. This means less CO2 is stored at the bottom of the ocean, and because the organic matter stays stagnant, bacteria began breaking down the excess poop, releasing CO2 into the water, which is then released into the atmosphere again. You may ask, why does this matter? Why should we care about phytoplankton? Well, other than the CO2 emissions they prevent and that they help produce a majority of the Earth's oxygen that we breathe, they're also the basis of a large majority of marine food chains. Declining phytoplankton and zooplankton populations can ultimately cascade up the food chain, threatening keystone species we know and love, like whales, and potentially causing ecological collapse. According to the UN, the ocean provides livelihoods for over 3 billion people, so this is a big deal. We need greater research funding to universities like the University of Miami and institutions like Canada's Yayyyy Institute, the co-authors hail from, that conduct this crucial research to better understand the impact higher up the food chain and analyze data in different regions of the world. If you've made it this far in the video, thank you for watching my technically complex video, and comment a poop emoji down below. It means a lot. Would you go swimming with all that fecal matter in the ocean? Also, this is my 31st video for the month, meaning I posted one video every single day this month in January and every single day of the year in in 2026, so I'm so happy. Let's go. Thank you for watching.